Hello dear friends, welcome to my channel. Today's discussion is Feynman path integral. Okay, understanding concrete concrete understanding of path integral. Okay, concrete understanding of path integral. Okay, so what is the meaning? Meaning is we know how to calculate and showing the theory using the question is that how to derive using Schrodinger theorem. Okay, calculation of an attempt to derive this Feynman path integral statement from our usual way of doing quantum mechanics, from usual Schrodinger theory. So how to derive using Schrodinger theorem. Okay, so recall this formula. X hat of t acting on x comma t, where x hat of t is Heisenberg operator. This is Heisenberg operator equals to x acting on x comma t. Okay, this is the Heisenberg operator. Now this it can be written as this way: e to the power I h bar t divided by h bar, okay, reduced Planck constant, into x hat into e to the power minus h hat t divided by h bar. Okay, this gate has a time evolution which is given by e to the power I h t acting on x. Okay, e to the power I h hat t by h bar acting on x. Okay, where this x is nothing but x at a time t equals to 0. Okay, t equals to 0. Okay, so we check these equations. Okay, this is my equations. This is my total equation. Okay, equation. So at a particular time t, the Heisenberg operator has eigenvalue x. Now, if you go t equals to 0, you take the corresponding Heisenberg operator and corresponding state. Then the operator has the state same eigenvalue. So the expression will be, this equation can be written this way: power I h hat t divided by h bar x hat into e to the power minus I h hat t divided by h bar comma t equals to e to the power I h bar t divided by reduced h. So it can be written x hat x. Okay, so you have to remember that this is equals to the state x. Okay, state x means t equals to 0. Okay, so this equation can be as written as x acting on x comma t, and that implies x cap acting on x is equal to x acting on x. Okay, so you can do the manipulation and you can use the same time evolution operator to calculate this matrix element. Which is my matrix element? Okay, my matrix element, okay, use x xf comma tf xi comma ti can be written in this way: xf e to the power I minus I h cap tf minus ti by reduced Planck constant x acting on xi, and written as n times an epsilon, where n is large and epsilon tends to 0, so n tends to infinity. So I can write limit cap infinity and n epsilon tends to tf minus ti xf e to the power h hat n epsilon divided by h bar xi. Okay, this operator can be written as a factor of evolution operator h hat epsilon. Okay, you can insert between this here and here the identity operator and the completeness relations. So this gives you limit n tends to infinity n epsilon tends to f minus t I integration dx1 up to dx n minus 1 xf e to the power minus I h hat epsilon divided by h bar x n minus 1 into x n minus 1 e to the power minus I h bar epsilon h bar up to x n minus 2 and x 1 and e to the power minus I divided by h bar h hat epsilon xi acting on xi. Okay, one has to calculate this matrix. One of them, this can be which matrix? This matrix can calculate. One can calculate this matrix. Okay, yeah, and this can be calculated in the following manner. So calculate this matrix. How can we calculate this matrix? Let's check. xf e to the power minus I h hat epsilon divided by reduced Planck constant x n minus 1. Okay, not n minus 1, this is just only n, can be written as x n plus 1 1 minus I h bar epsilon capital H. Okay, and x n. Okay, because e to the power, because we know e to the power minus h epsilon divided by h bar can be written 1 minus I h epsilon divided by h bar plus higher order term. Okay, higher order term is negligible. Higher order term. Okay, this term is negligible. Okay, this term is 0, so this is my value, so I get this from here. Okay, next friends, we can write this equation in this way. And you see the first term can be calculated easily because it just overlap of xn plus 1. The second term has h hat sandwich between xn plus 1. Okay, so I can write this way. This equation can be written as dpn using momentum. Okay, inside a momentum space identity operator. Okay, identity operator I can use. So dpn and xn n plus 1 p n, and it can be written as pn one minus I h bar epsilon h hat xn. Okay, so I am using identity operator, so no problem. Now we define each classical function pn comma xn equals to equivalent to pn and h hat acting on xn divided by pn xn. Okay, pn xn. Okay, you can use the standard expression of the overlap, which is 1 over square root 2 pi h bar e to the power I pn xn h bar. Okay, you can use. So 1 by root over 2 pi h bar e to the power I pn xn divided by h bar. Okay, so xn x dot n equals to limit epsilon xn plus 1 minus xn divided by epsilon. Okay, so integral dpn over 2 pi h bar, so it can be written this way. So my given expression can be written as dpn divided by 2 pi h bar integral, okay, e to the power I divided by h bar epsilon pn x n dot minus h pn xn equals to xn plus 1 e to the power minus I h bar h hat epsilon xn. Okay, this value we can get. Okay, so for epsilon is tends to 0. Okay, so now friends, whatever we have learned, we get this value. Okay, we get this value. Now we try to find out this matrix. Okay, this matrix we have to find out. This matrix I get this matrix value. Okay, now I can write this way: my path integral xf comma tf xi comma ti equals to limit n tends to infinity and n epsilon tends to tf minus ti. So it is dxi and dp0 dpi dot dot dp n minus 1 divided by 2 pi h bar dot 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 2 pi h bar. Okay, so more we can write this way, and it can be written exponential I epsilon divided by h bar summation n equals to 0 n minus 1 and pn x dot n and h classical function of pn comma xn. So this is my equation, and now you can say this is the path integral over the phase space, on it's also called Hamiltonian path integral, which is sometimes called Hamiltonian path integral. This equation is Hamiltonian path integral. So D, okay, box X and D P e to the power I divided by h bar, okay, and Ti to Tf dt into Px dot minus Hamiltonian and classical function x comma p. This is my total equation, and now I closed my video. Now I want to close my video. Before my closing this video, I will show my whole work. Okay, now let me show my total work, then you can understand properly. Okay, now check, this is the Hamiltonian path integral, and you can get get in here Hamiltonian path integral and check. This is this path integral called Feynman path integral, friends. And Feynman path integral and Hamiltonian path integral, I just derive Hamiltonian path integral from Feynman path integrals. And how can? Because from the Schrodinger wave equations. Thanks for watching.